So the requirements come from IT. What are you going to buy? When are you going to buy it? What's the next 10 years look like? Give me a 3, 5, 7, and 10-year plan. Even if you don't have a clue, let's sit down and figure out what it might look like. What functionality have we got to provide? Is this something that we can afford to have a little downtime on? Plays into the design of the facility. It plays into redundancy. If it's an internet-based company that you can afford some downtime because it's just going to switch to a different data center and the user is going to refresh, and to them it's relatively transparent, that's one thing. If it's a retail environment that's running sales across that floor, and if the floor is down, you can't sell anything, it's catastrophic. So that plays into redundancy, resiliency, and what your maintainability needs to look like. But everybody has to have input on their piece. And you've got to reflect current and future needs. You can look at your voltage that the equipment is going to run on. Can you get everything in there on 208? You can higher voltage, lower amperage, you're a little more efficient. You can use better power supplies, but you've got to talk to the IT folks, because if they just order it, then they don't have the knowledge that we share. They don't really think too much about efficiency of a power supply. They don't think too much about the power factor at the incoming, the service entrance to the building. But we're going to think about that because we care about what the bills cost, right? If we can lower the electric bill, we can give that money back to the chief information officer so that they can invest in better equipment and we can do more business quicker and the company makes more money. Design should entail if you're going to feed from above or below. How many of us have a problem with cabling, power feeds, and things like that under the raised floor? The design phase is when you get ahead of that. You can go back and retrofit. It is completely possible to clean out, but that's generally after the fact and you already have a problem. So everybody needs to agree in the design phase. Are we going to feed our power from under the floor, or are we going to do overhead distribution? Are we going to have all our structured cabling under the floor? Are we going to put that overhead where it's seen? And when it's seen, it will be neat. That fixes a lot of problems. Structured cabling design, you should have your structured cabling individual, whether they are internal to your company or a third-party contractor. It's critical that they are in the design when you start drawing the rooms, because how the cabling flows around that building will dictate if you can get structured cabling to the devices where you need it within the distance limitations, or if now we're going to start building more cabling closets. Whereas a design that took that into account and maybe more centrally located things, because you got a 300-foot distance on copper. Fiber's a lot more forgiving, but typically your users are only so far from that copper origination point at the switch. So you can locate 2 rooms in a manner that will cover enough area that you don't have to have 4. Trunking systems and top of rack switches can help a lot with speed, but they come with a cost. But the growth factors is what we're talking about. They have to include the anticipated changes in technology. Do you think your mainframe system might go to water cooled? Do you think your systems might go to cloud? IT has to answer those questions. And expansion and consolidation are both big drivers in technology. We've seen server densities go from thousands of individual pizza box servers down to 1,000 in a rack now. And that one rack is fairly dense and requires quite a bit of cooling individually, but nothing like the old racks and racks and racks of servers. When you're looking at your growth factors, that needs to be projected and calculated by technology type. Don't consider a 10% overall data center growth, 10% power and 10% cooling. It's more how many server percentages am I going to grow in that arena? How many percentages am I going to grow in network in that arena? And your network types Are you going to be into some of the larger switches that have airflow that is side to side instead of front to back? That requires a rack all of its own type. And it really, really screws with your hot aisle, cold aisle configuration. Increases and decreases in environmental requirements across platforms are almost never uniform. So getting out and talking to folks and seeing what they're seeing coming down the pipe, right? They go to seminars and educational opportunities like this one that are focused in their areas. Generally, they've kind of got a good idea of what things are going to look like in at least 3 years out, if there are any big changes coming down the road. Your primary basis of design when you sit down and figure out what the building needs to look like, type and number of racks, and then power requirements. A lot of people don't really use watt density anymore. I still kind of personally like it. Watts per square foot gives me an idea of how much power that I need to get in that room total and how much cooling I have to deliver per rack to meet X number of watts in a rack. And if you do need to scale, equipment designs come into play so that you can meet speed to market for your company. Do you have communications proximity requirements? Believe it or not, SCSI cables are still around. You still have to put equipment close to other equipment because it can only communicate 20 feet away. When do I engage the design professionals in the process? Usually I start with an architect. Start with an architect, begin to talk about what does the building need to do? Does it have storm resiliency properties that we have to meet? Does it have to be always on all the time? Is it something that we're in an earthquake zone and we need to consider those variables? Because that's some construction that, earthquakes, tornadoes, hurricanes are probably one of your more predictable impact items, but tornadoes are hard to test, right? Earthquakes are really hard to test. And there's a lot of theory that goes into building that stuff. So for tornadoes, you've got the FEMA P361 that kind of gives you the guidelines for building a storm shelter. And you can use those guidelines to create a resilient facility. But it's hard to get an F5 tornado to run by and test it for you. So Underwriters Laboratory does some testing where they fire 2x4s at concrete slabs and other types of materials to check for damage and to say, yes, this will meet the FEMA requirement or it won't. And then you always have the ability to say, I don't want to only meet that requirement, I want to exceed it. So we're going to take a material that meets it, and maybe that's a foot thick 3,000 PSI concrete, and we're going to make it a foot thick 5,000 PSI concrete, or we'll go to 18 inches. Really the driver is going to be the board of directors for the company and what kind of resiliency do they want versus how much does that resiliency cost. And again, back to economies of scale, it's not that much to go from an F3 to an F4 and not that much more to go to an F5 tornado rating on any of this construction. But a lot of it depends on where you're at and what's your primary risk factor. The cheap part of the building? Yes, the envelope is ultimately the cheaper part of the building. You're absolutely correct. Right. Yeah, generally your power plant is the most, power and cooling is the most expensive, with power being more expensive by far, especially if you want a lot of redundancy in your generation and UPS systems.